sorting and searching. Searching, as most of you guys know, like searching, I wanted to start with binary search, uh, and many of you already know about that. We will get into detail about it, but just to give, since you know about it, binary search is one of the important area from searching, uh, that is used so much, so we need to be very much used to the thinking and template part of it, because that is used, that another version of the binary search, multiple version of binary search used at multiple places. Coming back to sorting, that will be the focus area for today and the next session. The important sorting algorithm, from my point of view, that you should know, consider from understanding and reading and writing purpose as well, is about the bubble sort. Let me write it this way. Okay. So bubble sort. Second one is the selection sort. Keep some space here. Insertion sort, quick sort, and merge sort. These five sorting algorithm is being used so much that there are so many problems are derived from this sorting algorithm. So this also, you think you can consider this as a template, similar to the one, the traversal part what we have seen. So this is also, each of these would be template one, which you should be very much used to it, and these templates will be used in many problems. These are the building blocks basically of the algorithm, sorting and searching. Okay, so these two, basically these sorting, I would further categorize into these two. Okay, now the categorization is based upon its simplicity and the performance. For these three sorting algorithm, the time complexity are O of n square. What does that mean is we will discuss now. And for these sorting algorithm, the average time complexity is n log n. Mostly these sorting algorithm is used because of its time complexity, which is better than n square. We'll get into more onto it. For now, bear with me. Focus more on the coding part of it, understanding part of it, instead of time and space complexity. So this is being used generally for the sorting because of its better performance than other three. But this is a good for understanding the coding skills, I would say. And this pattern could be used for basically solving multiple algorithm, and it is easy to understand, easy to code. So first we need to get hands-on on into these three, at least to be an expert area. And this is something quick and merge sort. We need to be, my expectation is you should be able to understand and explain this very well. And with some help, you will be able to complete the code. My expectation would be not that like you would be able to just write the code for this at any point of time. You would need to think about it, like when you write a code, as much as you understand how this algorithm work, it would help you to write the code. It depends upon that, but initially it is fair assumption to assume that with some help, if you are able to write this code. Starting with the bubble sort and selection sort, these two are very closely related to each other. Now our goal is to sort this integer array and have the result as at the end as 3, 4, 5, 6, and 8. Now this is a sorted array. That is a requirement. What is the benefit of sorting array? We'll talk little later. But right now our goal is to sort this array. Now how can we sort this array? Thinking about these approaches, right? Instead of just going through and looking at the code from the bubble sort and selection sort, right? Trying to understand the concept, pattern based, that will help us to solve some of the integer related in the similar way, right? It will help us to solve how we basically arrange these numbers to get into some of the requirement, whatever have been asked. the requirement is, that will help us. So that is the goal exercise. How bubble sort work is, bubble and selection sort, these are the two basic sorting algorithm. And then there is insertion sort, which is little different with bubble sort and selection sort in the strategy, but at worst case it also gives the time complexity of O of n square. And in some cases, which we will see, the bubble sort could be the best sorting algorithm of all these, which could give us the result with O of n time complexity. But we will talk about that later on. So let's focus on this problem solving skills about this. How does bubble sort work, right? If you wanted to do a sorting here in this use case, okay. So with bubble sort, basically we compare the two element at a time, and whichever is the greater element, we put it at the right side of it. Our goal as part of the bubble sort is to sort from the right side of it, putting the greatest element at the end and then moving towards the last element so that our array is sorted. Okay, that is the goal, to have our greatest element at the end, keep it here at this position, and then in the next iteration we want to have the second largest element at this position, third largest at this. This is how we will be reducing the loop. And once we are here, it means the array is sorted. That would be the goal. Now, how can we do this? So since we need to work towards this, putting the greatest element on the right side of it, one by one, so that the greatest element is here at the end. Then the second last, third last, fourth last. Between 5 and 3, if we see, if this element is greater than this, then we wanted to swap. So now if we swap this, this become 3, 5, 8, 4, 6. Similarly, in the second iteration, we wanted to do this. If this is greater than we wanted to swap it, it is already in the right position. Then we will have a third iteration for this. So this will swap 3, 5, 4, 8, 6. And in the last iteration, we will swap and this becomes 3, 5, 4, 6, 8. As we have seen earlier, the position of it is fixed now. This is the right position. Now the same exercise we wanted to do for this. So 3, 5 is sorted, then 5, 4 will replace. So this become 3, 4, 5, 6. And this is already sorted. 6 is the right position now. So this two position is changed. Now the same exercise will happen for this, and then this, and then this. At the end, we will have 3, 4, 5, 6, 8. Okay. This is the simplest sorting algorithm. So we'll move little faster. But you need to understand, if you always think about the difference between bubble sort and selection sort, we all know that each and every element is compared every other time with all the elements. That's why the time complexity is O of n square. Let's get into it little more. So now again, this is something kind of a divide and conquer approach. It means first we are running a loop for making this any greatest element to be placed here. I repeat again, any greatest element to be placed here. This is what we are doing from this first iteration. And in the second iteration, we are planning to put the in this group, right? Divide and conquer approach. First we have divided it and now we are conquering it here. In this element, putting the greatest element at this position. So now you see this is a repeated exercise again. One thing which we are repeating it here, then we are repeating it here, then we are repeating it here, then we are and how many times are we repeating? We are repeating as number of elements in the array 5 times, because this we are repeating one, the entire exercise. This is 2, this is 3, this is 4, this is 5, this is 6, right? And what we are doing, we are again comparing this, then this, then this, then this. For every element we are comparing to the next element, then we are going to the next element, comparing with the next element, then we are going to the next element, comparing with the next element, then we are going to the next one, comparing with the next element. So you see, this is one iteration, and the other one is the second iteration where we are targeting for the last element. It means for this element one, iteration one, inside that we are doing all this to keep it here. So now if you see, second time we are doing for this and keeping all the element to here. So now with this pattern you would see that this is also dependent upon n, number of item we are doing iteration. This is also dependent upon n, because every other element is comparing with the next element. If we just skip one of the element, right, at every iteration. So since this is a repeated thing which we are doing, now we can think about like kind of a for loop here. What we are doing from I is equals to 0 to n, it means or n to 0. Basically this would be the n length of the array, and then we are going to one by one minimizing it, fixing for this, fixing for this. And inside for loop we are having another for loop where we are comparing all the j plus 1. If you think about this as an I, that is a pattern I would suggest. Always if you have a nested loop here, now we see that this is a nested loop here, and whenever we have a nested loop, think about as a pattern as a first loop as a I and second loop as a j. Easy to understand, easy to remember. So we have a one for loop where we are trying to fix the position for this, keeping the element at the end, and we have a second for loop which is lesser than the first for loop. Now let's think about snippet for it. For, let me change the color here. For int I is equals to 0, I less than n, I plus plus, we are doing. It means how many times we need to run the loop. This is a kind of a pattern. It means this, whatever we do, it will run for the n number of times. If you have a 5 element, this loop will run for the five times. 1, 2, 3, 4, 5. We wanted to fix this position. Now for this every iteration, what we want to do is we wanted to compare the next element, right? So now think about like for every time j is equals to 0, j less than, there should be something, but let's for now our understanding purpose, let's say j is still n, j plus plus. What would happen with this scenario? We are running this 5 loop for the 5 times, and every time we are running for the 5 times. 5 into 5 would be 25. For every one element we are running for the 5 times, this, that is why this become 25. And that's why our time complexity of O of n square. Whenever you have a nested for loop, you will end up getting the time complexity of O of n square. It would be little lesser than this, because at every iteration we have 1 and 1 it is reducing, like 5 into 4, 3, 2, it would happen like that. But I would take a separate session to explain you how you can remove the constants and why it is n square on an average. How do we consider this? Okay. So with this, now if we wanted to compare this element with this element, so it looks like a j plus 1, j and j plus 1. If j is greater than j plus 1, then swap it. Okay. So if array, let's say we have an array of j is greater than array of j plus 1, what do we wanted to do is we wanted to swap. Let's do a swap of array between I and j element. How does this swap function would like look like? We will see later, but this is how it is. Now what would happen as part of this exercise, right? Whenever j would start from here, j would compare, j would be swapped here, here, and at the end maybe j, when we are here, j is here, we will say j plus 1, we will get the out of index range exception, right? So that's why it has to be -1 for now. So now we understand that it has to be -1, because we do not want, right, the j should be here, j should not be here. This would be the last comparison. That's why -1. This is how, slowly we are trying to address the edge cases. First we understand what we need to do, and then how we are trying to understand it. This we have addressed one edge cases here. Okay. Now what would happen? For the first, when I is 0, j is compared with this, j and j plus 1, it will swap because this. Then this would happen, it won't swap, then this would happen, it will swap, and then this would happen, it will swap. This is done. First, I is equals to 0, we will get this array after debugging. 3, 5, 6, 8 is here. Okay. Now, next, again, when I become 1, because this is going to run 5 times, because n is 5, 0 to 4, it's this loop going to run 5 times. Now, again, what would happen is, again, this comparison would start. 3 will be compared, like as you were seeing, 3 will be compared with 4. So this is already sorted. 4 is compared with 5, 5 is 6 is sorted. Now 6 is all again compared with 8 here. That's okay. For now, let's go ahead, right, without decrementing it, but we can decrement it later. But it's okay. 6th position will be fixed by now because this will not be swapped. Again, what would happen? 3 and 4 would be compare, 4 and 5 would be compare. This is how, and ultimately this array will be sorted. But the important thing to consider here is how we are approaching is we are at a time trying to, compare these two elements, put it at the end, compare these two elements, put at the end, put at the end. So the greatest element would be at the end. But the other elements are not sorted because we have not compared this and this. That's why we have to start again the same exercise. But now you see, right, this 8 is sorted, 6 is sorted. Next time, if you're trying to sort, we do not want to compare 6 and 8 because we are addressing for the last element. Now, I is increasing, right? Basically, I is 1 initially, 0, let's consider as 1. Then I become 2, I become 3, 4, 5. As soon as the iteration is increasing, our element is also fixing. So now we understand with this, we can also do one thing. We can also add minus I here. So basically, this would be n minus I minus 1. This should be the condition here for j. Because we always wanted this j. First of all, minus 1 is because we do not want that condition to go out of index. That's why we added minus 1. So always this would be the best case. And next time, we do not even want it to be here. We want it to be here. Stop it here. In the next iteration, stop it here. In the next iteration, stop it here. So this is the code for the bubble sort with explanation, the time complexity,